Hey everyone, George Levy here. In this lesson, we're going to talk about forks. Specifically, we're going to look at hard forks, we're going to look at soft forks, and we're going to look at the difference between a hard fork and a soft fork. What's interesting is that Bitcoin has been through both, and it both happened on the same month. So Bitcoin now has been through a hard fork that created Bitcoin Cash, that brand new cryptocurrency that spawned off of Bitcoin, and now it activated SegWit by using a soft fork. In this lesson, we're going to analyze both hard forks versus soft forks, and we're going to end the entire lesson with a look at SegWit so you know exactly what SegWit is. Let's do this. In this lesson, we're going to be talking about Bitcoin forks and segregated witness. We will cover the following topics, starting with what is a fork. We'll then talk about a hard fork, which is what created Bitcoin Cash, that separate cryptocurrency that was created on August 1st as a result of the hard fork that took place on Bitcoin. We'll then talk about a soft fork. Segregated witness, or SegWit, was activated via a soft fork. We will explain what that is in this lesson where we go into soft forks. We will then talk about what is SegWit. Let's begin first with what is a fork. A fork, in its easiest way to understand, takes place when a blockchain splits into two different paths forward. Imagine that you're walking down a road and you come upon a fork and you have to make a choice. Do you turn right or do you turn left? If you're in the matrix, do you take the red pill or do you take the blue pill? Bottom line, a fork basically means that a blockchain splits into two different paths forward, and there are many reasons why that happens. Let's explain a hard versus a soft fork. A hard fork on a blockchain, in this case the Bitcoin blockchain, introduces a change that forces everyone to upgrade. And we'll explain more in detail what that is when we talk about Bitcoin Cash. A soft fork introduces change that is backwards compatible. What that means is that you don't have to necessarily upgrade. You won't get kicked out of the blockchain for not upgrading. You will not be able to do certain things because you didn't upgrade, but the fork can continue going forward and you can participate even if you do not upgrade. This is what happens with a segregated witness when it was activated. Some interesting facts about forks. Forks on Bitcoin happen on a regular basis, actually. Whenever two or more miners solve a block at the same time, for a moment they're separate chains, because a miner may have found the nons at the same exact time as another miner, and at that moment they're both winners. So at that point, both of them are leading the chain. Eventually, one of the chains wins over the other, and that's because the other miners need to verify, and then they keep building upon their blockchain. So the system self-regulates, and the more miners merge with one specific chain over the other, eventually the longest chain wins, and everybody follows that longest chain. When that happens, the blocks that eventually had won, but eventually were not the longest chain, become what is known as an orphan block. Those blocks are released back and the transactions are pushed back into the mempool, which is the place where transactions are kept waiting to confirm. So they're not lost, they're actually pushed back into something called the mempool. Let's now talk about a hard fork by looking at Bitcoin Cash. On August 1st, Bitcoin Cash was born out of a hard fork. In fact, it was a user-activated hard fork, and that is because the miners decided to implement this hard fork that would create Bitcoin Cash. That took place on August 1st, 2017, and specifically at block 478,558. When Bitcoin Cash activated the new protocol, it caused a split in the chain. And it was a hard fork because whomever had not already implemented an upgrade to follow along with the new chain couldn't follow along. And that's why Bitcoin Cash went off on its own path while Bitcoin continued in the other direction, because many of the miners that were on the Bitcoin blockchain did not upgrade to the Bitcoin Cash protocol. Let's look at it in a different direction. When we look at a blockchain, the Bitcoin blockchain is a constantly updated ledger of transactions all the way back to the Genesis block. That's block number 0, which is where the whole Bitcoin network and the Bitcoin blockchain began. New blocks are added approximately every 10 minutes with the latest transactions, and each of those blocks contains a cryptographic hash of the previous block. This is what forms the blockchain. They're all tied cryptographically together. On August 1st, there was a new type of block that was created, a 1.9 megabyte block. And that's because VIA BTC, the pool, was already running the Bitcoin Cash protocol. This caused a split because the Bitcoin Cash protocol actually allowed for 8 megabyte blocks, while the rest of the Bitcoin protocol did not allow for the 8 megabyte blocks. This caused a split in the blockchain. The ones that would subscribe to the 8 megabyte block, that's what created Bitcoin Cash, and the ones that were still at the 1 megabyte limit continued on the Bitcoin blockchain. Let us now look at a soft fork by exploring how segregated witness was activated on Bitcoin. To be exact, the soft fork took place on August 24th, and it was done through a process called a UASF, or User Activated Soft Fork. Segregated witness was locked in on the 8th of August 2017 at block number 479,707. Notice that this is a higher block than the 478,558, which is the block where Bitcoin Cash split off. So by now, the segregated witness soft fork was taking place on the Bitcoin main chain, not on Bitcoin Cash. Bitcoin Cash has nothing to do with segregated witness. It's a separate cryptocurrency by this point. Notice that segregated witness was not activated on the 8th of August, but rather on August 24th. This soft fork with segregated witness did not cause a split in the chain. Some of the changes, and I'm going to be explaining what segregated witness is that it replaces the block size limit with a different way of measuring the space by calling it the block weight limit, and this frees up some space. I will explain more in detail as we go on with this lesson. What took place on August 8th at block number 479,707 is that there were enough miners supporting this segregated witness mandatory activation that it was locked in. It was going to happen. However, the process needed to continue until block 481,824 when the system activated segregated witness and it became live. Now, what happened at block number 481,824 is that the nodes that were running segregated witness were starting to create transactions including segregated witness. Notice that there isn't a split, because you can still run Bitcoin transactions the old way with the 1 megabyte limit, but there's now this new functionality called segregated witness. And what that means is that the miners that have already upgraded to segregated witness can begin to process and create transactions using segregated witness. However, any miner that has not upgraded yet to segregated witness would still be able to remain on the chain. However, they would not be able to participate in segregated witness transactions. Let's discuss now what is segregated witness. Segregated witness at its core is a protocol upgrade. It basically improves the scalability of Bitcoin without increasing the block size. SegWit also works to address a vulnerability in Bitcoin, which is called transaction malleability. SegWit works to resolve this transaction malleability. The soft fork that was presented for segregated witness does not require upgrading to remain on the blockchain. What that means is that miners that have not upgraded to segregated witness can still remain on the blockchain. They won't have access to all the functionality that segregated witness can provide and also being able to participate in segregated witness transactions. However, they would still be able to validate blocks that do not include segregated witness information in them. As a result of the soft fork, segregated witness did not cause a split in the chain. Now what we'll do is we'll analyze what segregated witness is. To do that, let's first look at the contents of a Bitcoin transaction. A Bitcoin transaction has three main components. The first one is an input, and the input is where the coins are coming from or wherever the funds are coming from. It's got the amount, as in how many Bitcoins came in from a certain source. And the output is where those Bitcoins are actually headed, where they're going to be going. Those are the components of a Bitcoin transaction. A good way of looking at a Bitcoin transaction, even though it's not exact, but it's a good image to keep in mind, is that a Bitcoin transaction is very similar to a check. You have an input, which is where the Bitcoins or funds are coming from. You have the output, which is where they're going to be headed. And you have the amount of those Bitcoins that are going to be headed out to this output. And in order for a transaction to be able to happen when somebody has Bitcoins, they need to be able to sign that transaction. And that's how you can make sure that your Bitcoins are not spent by someone that's not authorized. This is because you have the private key, or your wallet rather, has your private key and is able to sign every transaction, which only you control the private key. So that means that nobody else can spend your Bitcoins. This is the digital signature. Now, in a SegWit transaction, what happens is that this signature data, which is also known as the witness, is segregated to an extended block. That is, it's pulled out of the main block. And this is part of that change that we put as the block size limit versus the block weight. The digital signature information is pulled out into an extended block, which is separate from the transaction. This frees up approximately, it's estimated, between 60 to 63% of the data of the actual transaction. It's consumed by the signature data. Additionally, a key thing that SegWit does is that it includes the input and the amount, that is the transaction information, as part of the digital signature. In this chart, I'm right now showing the percentage of transactions that are segregated witness. And what you're going to see is, as time goes by, more and more segregated witness transactions will be forming part of the mix of Bitcoin transactions that are taking place. This will eventually lead to less congested networks, and it should also reduce transaction fees.